Yes.
And we did oobleck stuff. The first lab we did, was that a combustion reaction?
Oobleck?
Yeah.
No. Oobleck was not. Huh?
One that gave off boots, I thought.
Yeah, it's an exothermic reaction, but it's not a. No, it's not a combustion reaction. Yes. Oh, wait a minute. I've actually written the wrong thing down. This should be. This is CO3 over here. Okay. We're going to find that. We'll probably find this out today or tomorrow why it's a solid and not aqueous. Okay. All right, we're now in Unit 5. In Unit 3, we first started learning how to name compounds. Okay? Naming compounds will help you identify when you have a two-part compound or not. Okay? Naming compounds will help you identify when you have a two-part compound. Now, so if you know how to name this, you're going to look at it and say, hey, I have more than two elements. There must be what in this formula? Polyatomic ions. So I'm going to go to the polyatomic ion list called the common ions list, and I'm going to find those names. And when I do that, I find this is ammonium, and that's carbonate, and that sounds like a two-part compound, doesn't it? Okay? And it is. You've got an ion here and a separate ion here. That's two parts. Okay? It's not the way, not the absolute end of it, but it helps you figure it out. Okay? So I have a positive ion and a negative ion. That's a two-part compound. Okay? So you could call this A and B if you wanted to. All right? So is this going to be two parts or one part? Magnesium sulfate. That sounds a lot like it's two parts. And if you look those up, you can see it's a magnesium ion and a sulfate ion. So that's a CD. Now, if those things switch around so that A goes with D and C goes with B, then it's a double replacement reaction. So let's look over here. There's my ammonia, or ammonium, which is A, and there's A right there. There's the sulfate, and there's the sulfate there, so I call sulfate D. I'm going to call it D here. So those indeed went together. And over here, the C part was magnesium, the carbonate was B, so sure enough, they joined up together, didn't they? Therefore, we classify this as a double replacement reaction. And what do we use to balance equations? Yes, we use coefficients to balance them, but what is the tool we use? The AI, the atom inventory process. So we go through and we list all the elements in all these formulas. We make our little spreadsheet. Yeah, it works out a lot better if you keep that center line under the arrow, because that's the dividing line. That way you can keep everything on this side of the equation over here, over on this side of the spreadsheet, everything on this side of the equation on this side of the spreadsheet. Okay? So let's see, this 2 outside the parentheses here means I multiply everything inside by 2. Therefore, I've got 2 nitrogens and 8 hydrogens here. Okay? I have 1 carbon. I've got 3 oxygens here, but I've got 4 more over there. So I've got a total of 7 oxygens. Okay, I've got 1 magnesium and 1 sulfur.
Hold on. So you just count how many links of these?
I'm just counting how many of each of these atoms I have on this side of the equation. I'm putting in this part of the spreadsheet, or the grid, or the graph table. Well, it's not really a table. Okay, over here, there's the NH4 again with the nitrogen in it and the 2 outside of parentheses. That means I've got 2 nitrogens and 8 hydrogens. Okay. Look for carbon next. So I've got 1 carbon. Look for oxygen next. Got 4 here and 3 here. That's 7. Magnesium. Just got 1 of those. Sulfur. Just got 1 of those. It's already balanced. I don't really have to do anything more with that. But you have to show me the atom inventory to prove it. Because I'm from Missouri. Go and look up the slogan for Missouri. Huh? Not right now. Do it at home.